So today AMC 8 2023 version. Let's start. What is the value of 32 plus 2 minus 8 plus 8? So 18. Square pieces of paper folded twice into 4 equal a quarter, and here. So this is the folded and closed part. So we can tell it has the inside, the hole, and also because we have the square corner, this corner are here, and the cutting line is not exactly same with the corner, which has this like a diamond shape. So we can guess this can be E. Wind chill is measure of how cold people feel. So 0.7 wind speed. Oh, it's interesting. So now temperature is measured in Fahrenheit. So air temperature is 36 Fahrenheit minus 0.7 times wind speed 18. So 12.6 for 23.4, so 23. Numbers from 1 to 49 arranged in spiral pattern, and we put like this, and how many primes? So here 49, 1, 2, 3, 4, 5, 6, so here 43, 37, 31, and now 5, 26, 5, 21, 5, 16, 5, 11, and 4, wait. This is 5, right? This is 5. And this is 4. Okay, not. Here 17. And again 4, 13, 3, 10. Like this. So now we can tell here is 19 and 23. 47 and 35. Oh no, I mean 39. So not this one. 1, 2, 3, 4. Oh, but not 7. So 3. Lake contains 250 trout along with the other fishes. Okay, 180 fish from the lake, 30 identified as trout. So we can tell out of 180, like generally, there are 30 trout, which is 1/6. So assume the ratio same. How many fish are there in the lake? So now we can tell 1/6, but we know there are 250 trout in the lake, so we can tell total like this. So this becomes a 250. So now times 250, 1,500. 2023 placed in the expressed below. Maximum possible value of the expression. So we'd better make as large as possible. So the largest number could be 3 to the power of 2 and 2 to the power of 0. So in that case, this is 9. But let's say 2 to the power of 2 times 3 to the power of 0. No. Because of 0, actually, we cannot avoid 0 or 1. So other than that, we can make the largest number on the other side. So I think this can be the largest. Rectangle side prior to x and y axis opposite 15,3 here, and okay 0,0. Okay, How many points on the rectangle lie on at least one of these two lines? A, B. So 3, 3, 3, 3, 3, 3, 2, 2, 2, 2, 2, 2, 2, 2. So only 1 point, at least one of the two lines. You know, usually when you attend this kind of math competition, you cannot use like a ruler or protractor or something like that, compass. So it's better to find a way to adjust your own way to measure or something. So now I just try to keep the slope. So we found only one is on the line. Lolo, Tia, Tio, ping pong tournament. Okay, win or loss. So altogether, yeah, I mean altogether win or lose. So here 2 win, it should be, we need to make 2 lose, so 0. 2 win, 2 0. 2 win, 2 0. 1 0 1. 0 0 0 1 0 1. And Malaika is skiing on the mountain elevation. Okay, so between how many seconds does she spend between 4 and 7? 4 and 7. Okay, so here 2 seconds, here 4 seconds, 2 seconds, altogether 8. Harold made a plum pie to take on picnic. Only quarter of the pie, he left the rest for his friends. Left behind. Okay, so let's say he had X amount, and now after he's eating, after the one action finish it, we only have 3/4 of X, and Moose came over and ate 1/3 of what we have behind. So now we have 2/3 of what we had. So after that 8. So now we have half of the pie. Now purple pine ate 1/3. Okay, so now we have 2/3 of what we have. So we have 1/3 of the cake. NASA's Perseverance rover was launched delayed. Okay, after traveling this amount of miles, landed on Mars 6.5 months later. Okay, found closest to the speed, miles per hour. So 292.526.838 over now mile, and we have 6.5 months. But we need to make from months to hours. So we know 1 hour, let's say 1 month. 1 month has 30 days. 1 month, 30 days. And 1 day has 24 hours. So here, let's not think about too much because this is all approximation. I mean, the answers are all approximation. So let's say 300000000, and we have 30, 6.5, and 24. So 30. And now we have like this, and 13 times 12. So let's say this is 144, 12, 156, something like that. But let's make it 160 or 150. 160, let's say. 5, 80, 6, 96, 40, and 2, blah, blah, blah. So how many zeros we have? 1, 2, 3, 4, because we can make from here 1, 2, 3, 4. So this may have 60,000. So this is all approximation. I mean, the calculation should be approximated, not to make it too complex. Figure below shows a large white circles, a number of smaller white and shaded circles as an interior. What fraction of interior white circles is shaded? Okay. So now we can tell 1, 2, 3. So 9 pi, this is total. Pi r squared, 9 pi is total. So this one, this is a half. So half squared pi, but we have 3 of them, plus this one, we need to find this one and subtract 2 of this. So 4 pi minus 1 pi, which is 2 of 1 pi. So this is eventually 2 pi. So 4, 11 pi times 9 pi. So 11 or over 36. Along the route of bicycle race were 1, 2, and 7. 2 repair stations evenly spaced between the start and finish lines. Okay. Third work station located 2 miles after the first repair station. How long is the race in miles? Okay. So we can see when we have these 7 stations for water, there are spaces 1, 2, blah, blah, 7, 8. So we have 8 spaces. So if we call this, let the distance d, then the water space for water stations is d over 8. But if we have 2 repair shops like this has 3 spaces. So for a space for the repair shop is d over 3. So let's say third water station, which is 3, the 3d over 8. This is the location of third water station. Located 2 miles after. So after means this is further than this one. This is d over 3 plus 2. So 24. I'll multiply by 24 together. And 90 becomes 80 plus 48. So d becomes 48. So the race in miles is 48. So Nicholas is sending the stamps to his friends, exactly 20 of each types, and make it 710 cents with 5, 10, 25 cents. Nicholas is planning to send a package of the Nicholas is planning to send stamps to his friends. 5, 10, 25 cents stamp altogether, 710 cents, each 20. 5x, 10y, 25z becomes 710. Divided by 5, 2y plus 5z can be 142. So let's say x maximum 20, 90, 80, something like that. Because x is the key to arrange the, like match the last digit. So we don't know which one is the best option. So let's try when x equals 20. 2y plus 5z becomes 122. So last digit should be 2 to make it, because this can be 0 or 5. So this should be 0. So here we can make it last digit of 2, which is 2 times 16, 32. When this is 32, 90. So 5 times 18 to make it 90. So now y becomes 16. This is 18, which is 54. Let's talk about the when x equals 19. So 2y plus 5z becomes 123. So here, this should be the last digit of 5 to make it odd number with even number. So this is the last digit, should be 8. So 38 plus 85. Yep. So now the 2 times 19, this is 5 times 17. So 19 and 17. So 39, 38, 55. Oh. Actually, we don't need to go further because we already have the maximum option here. But let's go for the 18. 2y plus 5z becomes 124. So this should be last digit 0, and this should be 4. So 34 and 90. So this is 2 times 17, 5 times 18, 17, 18. So 35, this is 53. Oh. Okay, so now we have 55. Actually, there will be more options, but we have the largest option here. And for the next one, Bisam walks half a mile to get to each school. Half a mile, so 0.5 mile, but consists of 10 blocks. Okay, so block 1 to block 10. Each of them are equal lengths, so 0.05 mile. So today, after walking 5 blocks, he discovered he has to take the tour walking 3 blocks of equal length instead of 1 block to reach the next corner. From the time he started his detour was speed. This is a little bit confusing. So he takes 1 minute. So usually his speed is half a mile over 10 minutes. This is his normal speed because it takes 1 minute for each block. But today he need to walk. He walked to 0.25, which is 5 blocks, with maybe 5 minutes, because this doesn't have any changes. So he finished his half, but he has to take the tour, walking 3 blocks of each length, instead 1 block to reach the next corner. So I'm just confusing the next corner, just like 1 corner or like all other 5 corners. Let's make it all other 5 corners. But he wants to make the same time. So the time, distance, speed, time. So time should be distance over speed. So his usual time is distance over speed. This is how he takes time, which is 10 minutes actually, literally 10 minutes. But he wants to make the same. So 0.25 mile over 5 minutes, which is 5 minutes, 0.25 mile. Plus now he has another, the half the amount of blocks, but all of them like increase by like 3 times. So 0.75 miles now. But we don't know what is the speed. So let's make the calculation here. So 10 minutes equals 5 minutes plus 0.75 over x minutes. So 5. So x minutes becomes 5 0.75 mile. This is minutes. So 0.15 mile per minute. But the question is the mile, not mile per minute, mile per hour. So 0.15 mile per 1 minute equivalent to 60 minutes to 1 hour. So here 1.5 times 6, which is 9. So maybe I was not correct. So this is not 0.75. So maybe only one block, detour only with one block. So so actually eventually he left 5 blocks now, but one block has like 3, like equivalent to 3 blocks because he need to detour. So now 4 plus 3, which is 7 blocks for him. So 7 times 0.05 mile. So now this is not 0.75, 0.35. So 0.35, so 0.07. So 0.07 in 1 minute. So now we can tell minutes, we don't have minute, 4.2 mile per hour. So number 16, letter P, Q, R, 20 by 20, P's, Q's, R's appear the completed table. So 20 by 20. I think just I'll start like this. So this is PQR, 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 PQR. So here, out of 20 rows, there will be start with by P, Q, R. So P, there will be 6 lines who start with P. 7. P, Q, R. PQR, 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 and PQ like this, 7, 7, 6. So this is how we start. So when we start by P, actually there are 7 P's, 8 Q's, and 6, 6 R's. So when we start by Q, 7, 7, 6. When we start by R, 7, 7, 6. You know what I mean? Because it starts Q, so QRP, QRP, blah, 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 QRP, QR. That's how we make 7. So QR. So here, RPQ, RPQ, blah, 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 RPQ, RP. So RP. So now we can tell all the number of p's 7 by 7 times 7 by 6 times 6 by 7. So 7, 7, 6, 6. 7 times 19. So the last digit is 3. So if p's last digit is not 3. And now q's. So 7 by 7 plus 7 by 7 plus 6 by 6. So let's say 49, which is 98 plus 36. Last digit is 4. So not B. But just to check the last digit for the R. So 7 times 6, 7 times 7, 6 times 7. So 7 is the same as P. 6, 7, 6. So it's the same, 133. Regular octahedron has 8 equilateral triangle faces like that. So when Q is there, next to Q, okay, so this and this will be, no. This and this together, so this may be here. So under the Q, there will be 2. So, and after that, next to 2, here, here. So now we assemble only here. So this will be 1. So next to Q, there will be 1. Is it a little bit confusing again? So here we fold 6, so that is 6, and 7 over there, and 5 is here inside, and 4 is below or inside there. So 2 will be here. No, I mean here. And 3 is next to 2. 3, 4 is there. So yeah, 1 is there. Grasshopper jump 5 pages to the right, 3 pages to the left. So with jump to the 5, make plus 5, jump to the left, make minus 3 left. And we want to locate 2023 out of that. So from here, 5R becomes a 2023 plus 3L. Because this must be easier because we can guess the last digit of 5R can be 5 or 0. So let's say when L is 1, oh no, I mean, not 0, 1, 2, 4, then 20, 35, and 4 or 7. let's check, because this was too easy. First, the number of jump make to reach the padlock 2023 pad to the right. First, the number of jump. So 407 to the right plus 4. So 411. Like number of jump. And 19. Equilateral triangle inside a larger, okay, ratio of the area of one trapezoid to the area of inner triangle. Side of length of inner triangle 2/3 of side length of the larger triangle. So this is 2/3. If let's say this is x, this is 2/3 of x. So here we can say this is 1/6x, 1/6x. And because this is equilateral triangle, so this should be 30 degree. So when that is a 30 degree, and we know the ratio of A square root of 3A and 2A, something like that. So if we calculate the A, so A 2 square root of 3, let me make it like this. A 2 square root of 3A becomes blank over 1/6x. So square root of 3, 1/6 square root of 3x. So the height is 1/6 square root of 3x. So the area is x plus 2/3 of x times 1/6 square root of 3x and half. This is the area of the shaded trapezoid. 3/5, 12 square root of 3 x squared. But now we need to calculate this largest triangle. Actually, if you know the formula, the equilateral triangle's area is, if there is the side length of x, then square root of 3/4 x squared. So now we can make the ratio to inner triangle. Oh, so we need to know inner triangle. So here, 5/3 times 12 square root of 3, 1 x squared, 2 square root of 3/4, 2/3 x squared. So 3, 12 square root of 3, 5, 2, 4, 9, 4 square root of 3. So 4, 3, 3, 3, 9. So let me multiply square root of 3 here, then square root of 3, square root of 3. So now 5/3 becomes 4. No, I mean 2. So 5, 2, 12. Two integers are inserted into the list, double its range. Now the range is 35. Range is maximum minus minimum, so 35. Mode and median remains unchanged. So we have now median is 8, mode is 3. So we don't make further. So we want to make maximum possible sum, 2 additional numbers. So because we want to keep the median as 8, so we better put 1 on the left side, 1 to the right side. So, but now we want to make maximum possible sum. So the numbers should be larger as larger as possible. So let's say if we put number 7 here, and to make it, 25. To make it 50, so we can put 53 here. So 2 additional numbers possible sum, the largest one is 60. I think. Then in that case, we don't change mode and median. Number 21. Alina writes the numbers from 1 to 9, separate cards, 1 card per card, 1 number per card. Divide the card into 3 groups and 3 cards so that some of the numbers will be the same. How many ways can this be done? So the sum from 1 to 9 is 45. So we try to make 15, 15, 15 with 3 numbers. So let's find any set of 3 numbers whose sum is 15 between 1 to 9. So let's say 1, 2, we cannot make it. 1, 3, no. 1, 9, 5. If we put 1, then we can make it like 1, 6, 8, 1, 7, 7, no. And this is what we can make. And 2, 4, 9, 2, 5, 8, 6, 7, 3, 3, 3, 4, 8, 3, 5, 7, 4, 5, 6, and no more. Right? No more. So this is the sets. Now we didn't consider the sequence. Just we can make this 1, 2, 3, 4, 5, 6, 7, 8 sets to make like subgroups to make the sum of 15. But there should be, because we divide by 3 groups, divide into 3 groups. So we need to find the way not to make them like repeated. So for example, 1, 5, 9 and 2, 6, 7 and 3, 4, 5, 3, 4, 8. This we can make. And let's say 1, 6, 8. 1, 6, 8, 2, 4, 9, 3, 5, 7. This is what we can make. What about 4, 5, 6? We cannot make it. 2, 5, 8, we cannot make it. Because among here, because those are more like, so there are, it all contains 5 or 4, 5, 6. So I think we can make 2 different ways, like divide into 3 groups. Because if we have 4, 5, 6, then we can use the number 1 into the other groups, for example. So, yeah, that's the one. Number 22. Sequence of positive integers. Each term after the second is the product of previous 2 terms. 6th term in the sequence is 4,000, the first term. So let's say A, B, AB, AB squared, A squared B cube, and a cube b to the 5. 1, 2, 3, 4, 5, 6. This is sixth term. So a to the power of 3, we have 3 a's, 5 b's, which is 4,000. 4,000 is 4 times 1,000. So 4 is 2 squared. 1,000, 2 times 5 and 3. 2, 3, 5, 3. Like this. So 5 to the power of 3, 2 to the power of 5. So we can tell the first term should be 5. Number 23. Each sequence in 3 by 3 grid randomly filled 4 gray and white tiles to the right. What is probability that tiling will contain a large gray diamond in one of the smaller 2 by 2 grid? Okay. So for example, it can be here. Then the shape of these 4 are fixed, but here, 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 here can be any of the tile. So 4, 4, 4, 4, 4. So 4 to the power of 5. Plus, again, same way. If there is the tile here, the diamond tiles, then again 4 to the power of 5. If we have diamond here, let's say again 4 to the power of 5. In here 4 to the power of 5. So now we have 4 different cases of 4 to the power of 5. So this is the case of what we have for the diamond. But actually, the total case of the arrangement is 4 to the power of 4, 4, 4, blah, blah, blah. So 4 to the power of 9. So now we have 4 to the power of 3. So 1 over 64. Isolate triangle ABC equal lengths 11 and 5 respectively. And now we have ABC have the shaded portion of ABC. They are same area. Okay. So this is, we know, So this is 1 and 1, which means this area and the large area, the ratio of the area is 1 to 2. Area ratio is 1 to 2. Then length ratio is 1 to square root of 2. This is what we know. For example, if we have 2 squares and the length is 2 and length is 3, the ratio is 2 to 3, but area ratio is the squared because the area comes calculating by squared. So 4 to 9. This applies to any shapes because when we calculate the length, we multiply 2 different dimensions, like a base and height, length and width, something like that. But 2 dimensions, all of them, they get affected by this, like the stretch or compression. So here, base twice, height twice, so area is twice of twice. So that's why length becomes like a square root 2. So here, this was 11, and this is 5. Oh, Oh no, I made a mistake. So isomers ABC equal side length ABBC. So let's say base length B. Isomers ABC has equal side length. So let's make AC as the length of B, which means base. And height, we don't know what is the real height. Let's call it 8. So now they have the same area. So here 11 minus B. No, I mean 11 minus 5. No, I mean H minus 5, sorry. So here H minus 11. So this is the one. Let's make it. So the area here, we need to guess here. 11 to 8, because this triangle and large triangle are similar. So 11 to 8 is, let's say, x to b. So x is 11b over 8. So the trapezoid area is 11b over 8 plus the b times h minus 11 and half. So this is the shaded area on the left side, and on the right side again, h2, h minus 5. So here again, y, b to y. 11 to x, h to b, h minus 5y. So y is b h minus 5 times over 8. So this one, h minus 5 b over h times h minus 5 over 2. So 2. Actually, we can remove b, h, b. 11 plus h minus 11, okay, equals hb, h minus 5 squared. So b, h. So h squared minus 121 becomes h squared 10h, 25. So 10h becomes 141. 146. H becomes 14.6. We have 15 integers from A1 to A15 arranged in order on a number line, and we don't know where are they exactly, but we know them. They have same space, same difference, which let's call it D. So A2 is A1 plus D. A15 is A1 plus 14D. So let's say between them, I want to know what is D. So when you subtract the two these inequality symbols, you need to find the largest and smallest number. So largest one is 20 minus 1. So 19. Smallest is 13 minus 10. So 3. Okay, so this is a little bit. And what about here? 13D. Let's subtract them. So from here, the maximum is 250 minus 13, 237, 221. So divide by 13, divide by 13. So here, 221, 13, 13, 91, 7. Oh, okay. So D can be from 17 to 37 over 13. maybe 18, 107. So 18 blah blah blah. So now we can tell D can be 17 or 18. And let's figure it out whether it is real possible or not. So this is A1 plus D. This is A1 plus 14D still. So now here A1 is 1 to 10. So A1 plus D, if it is a 17, let's say, then 18 to 27. So still A2 can be 18, 19, 20. We don't know which one it is, but anyway, it can be. So here, 14D, 17 times 14, 34, 68, 17, 238. So 238 plus here. So 248, A15, and 248 here, 239. So between here, A15 can be 241, 248. So anyway, both of them possible. Let's go further. It's a little bit. And if it is 18, let's say, then A2 can be 19 to 28. So it can be 19 or 20. 18 times 14. 72, 18. So 252. So 253, 2. So this cannot be. 262. So D is a 17. So now we determined what is D. D is a 17. So from here, to make A2, A1 plus 17, and A1 plus, what was it? A1 plus 14 times 17. So 238. So now this was 18 to 27. Here 239 to 248. So let's say if A1 is 1, (18, 19). A2 can be 18, 19, or 12. A3 can be 239, 241, 242, 248. So now let's see, because this is A1 plus, because now we fixed it, D is 17. So in that case, A1 can be 1 or 2 or 3. And not A3, 15. And A15 can be 3 or 4 or blah, 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 because this is 238. So which means A1 is 3. So now we know A1 is 3 and D is 17. So A14 is 3 plus 13 times 17. So 170 plus 51, 221. So 224. So all digit 2 plus 2 plus 4 becomes 8.